Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, so I think we're going to get started here. Thanks everybody for coming out. We're going to have a little presentation today about an interactive program that's offered at Harvey Mudd College, which is I'm sure many of you who are here are familiar with it. It's a small undergraduate engineering school. They offer a clinic program in which there's some interaction between the industry and also the research that they do there. And we're going to learn a little bit more about that from Bob Keller. Bob's been in the industry in the academic industry of computer science for a long, long time. He's been at University of Utah, Princeton, UC Davis, where I think he was the chair for a while. Mm-hmm. During my time at Harvey Mudd College, he was also the chair of computer science, and now he is the director of this clinic program. And we'll open this up for a little bit of a presentation about the program, and then there will be some questions afterward if anyone's interested.
Thank you, Jared. So the talk is structured. I'll tell you a little bit about Harvey Mudd College background sorts of information, some bragging stuff. Then I'll talk a little bit about the clinic program, how it's structured, kind of the timeline of how projects work. And then I will give some specific project examples of things that we have done in the past. And if there's time and interest, I also have a little bit about some of the non-clinic research at Harvey Mudd. So that'll be the structure of the talk. So we're located in Claremont, which is in Southern California. It's about 30 minutes from Los Angeles. And it's kind of a suburban campus. It's part of a consortium of 5 undergraduate schools, and there are also 2 graduate schools there, the Claremont Graduate University and the Keck Graduate Institute of Applied Life Sciences, which was founded in the last 4 years. We are a relatively small school, but one of our claims to fame is we have the program known as the Clinic, and actually is incarnated in a number of different departments. Computer science was the 3rd department to adopt this model. The first department was our engineering department, which started the model over 40 years ago. And they were the first and subsequently have been imitated by other schools and by other departments within Harvey Mudd as well. We also have a mathematics clinic and a physics clinic now, which is an option for people in physics majors as an alternative to doing their senior research. So it is a course, but it's a course with a different kind of orientation. It's not so much textbook and problem sets, but actually working on real-world problems that come from the outside. We don't initiate the problems ourselves. We ask for sponsors to give us problems to work, and we expect to return things of benefit to the sponsor, as well as provide an academic learning experience for the students. So it's a twofold set of objectives that we have. This is an example of here, these members are team members on a clinic project. The other people in the picture, I'm standing on the left, and the other people are so-called liaisons with the project, which is, in this case, it's kind of an extreme number of liaisons. Usually we have 1 or 2 liaisons that are appointed by the sponsor to interact with the team throughout the project. But in this case, we had quite a number of them. There's actually a couple of administrators there, too, that weren't liaisons in this particular case. So just to give you an idea of the kind of scope we're talking about, in 2003 we had a sort of anniversary celebration where the 1,000th clinic project that had been done by Harvey Mudd College was celebrated, and at that time we had more than 200 sponsors overall, all the years that we've done the projects, and we're giving out plaques and so on. You can see some of the logos of the sponsors in the background. Another sort of milestone was this past year we started what is called now the Global Clinic, which we're working with other countries and companies that span nationalities. So we have 2 projects that are currently joint between universities in Puerto Rico and Harvey Mudd College, and we expect to be expanding that program over the coming years. Computer science is not part of this yet, but it's clear that it's a thing that we certainly can engage in and will be doing in the future once we get up to steam with it. So that's just to give you an idea of kind of the direction before we get into the more of the specifics. And by the way, feel free to stop me with questions at any time, because I'm probably cover a fair amount of ground and it might be hard to come back to specific points. Why is it called clinic? The name was created by an engineering professor who said, well, it should be something like in medical practice where people don't go directly out of school and start operating on patients, but rather there's a period where they're kind of in a controlled environment, able to work and solve problems that are real-world problems, but still there's some kind of supervision involved. And so that's where the name clinic comes from. And we are trying to adopt a similar kind of model within computer science. Yes?
Is this done after graduation?
This is usually in the senior year, and some cases in the junior year. So depending on the student's how advanced the student is, he or she may take it in the junior year as opposed to the senior year.
So is this analogous to what's called design senior class, project class by other universities? Something that is
It may be like that. There's some differences, though, that will emerge. For example, it's an entire year project as opposed to a semester. And also, we actually charge a fee for it, and the client is thereby engaged that they actually want to see some deliverables actually produced. So there's a kind of a more interactive aspect to it.
IP, intellectual property.
The intellectual property is entirely the property of the sponsor, so we don't ask for any rights to the results. So, and that's actually in my next slide, is unlike a research grant, which many companies do provide to universities, the university does not ask for any rights in the results. And unlike internships, the work is done at Harvey Mudd College for the most part. There are some visits to the site of the sponsor, but most of the work is actually done on campus. And the faculty are there to help sustain supervisory role throughout the project, which is another difference from internships. So a little bit about our college. As I said, we're in Claremont, California. We're classified as a liberal arts college with an emphasis on science and engineering. So it's a kind of a hybrid sort of arrangement. But we're very selective. We compete with the very top schools, MIT, Stanford, Caltech. We are rich in the number of faculty. We have a 9-to-1 student-faculty ratio. Because we're very selective, we command very high performance on standardized tests before the students are admitted. And we have probably the highest percentage of our students in the country that go on for advanced degrees at some point after graduation. In the U.S. News World Report, which annually ranks colleges, we were listed as 14th out of 104 liberal arts colleges in this past issue, and we're also the #1 undergraduate, actually tied with Rose-Hulman Institute in Indiana, the #1 undergraduate engineering program. So some idea of the level that we come in. In Kaplan and Newsweek, we were referred to as one of the new Ivies. So comparing us to the Ivy League schools, we're obviously not on the East Coast, but we do have a sort of similar feel, you might say, to the Ivy schools in some ways. And actually, with our other schools in the consortium, Harvey Mudd is just one of 5, excuse me, it does have an effect similar to a small university. Excuse me. So in the core program at Harvey Mudd, I've listed here the requirements that all students must take. And as you can see, there's a fair amount of breadth in the sciences that is required, including 3 semesters of physics, exposure to engineering, chemistry, biology, and also computer science, which is perhaps last and least, but we hope to make up for that in terms of the things that we give the major. So also mathematics, of course, is very important in all these disciplines, and all students arrive with a background in calculus before they matriculate at the college. Our math department was designated as the exemplary program by the Math Association of America recently, and it's the first one to get this distinction. I should mention that we're strictly undergraduates. We don't have graduate students on campus, and we don't have TAs, for example. So all of our courses are taught by professors with PhDs. To focus a little more on computer science specifically, we introduced our major in 1992, and right now we're the second largest majors after engineering. We have about 30 or 35 majors per graduating class, and we're very proud of the fact that our faculty are not just focused on their own research specialty, but actually try to broaden out to cover most of the key areas of computer science, mainstream computer science. Our clinic program was started a couple of years after the major was started, and as I mentioned before, it was modeled based on the success of the engineering and mathematics clinics, which came before us. In our major, we have a number of different tiers. We have introductory courses. The first two, we require additional mathematics in the form of discrete mathematics. We also have what we call our foundation and kernel courses, which I'll explain more about on the next slide. And then students must take at least 3 technical electives and the clinic, which is kind of the capstone experience. They also do optionally independent research with faculty, either during the summer or during the academic year. So our foundation and kernel courses include data structures and program development, computability and logic, algorithms, computer systems, programming languages, and software development. And the last course is a requirement for our clinic. Before students can take clinic, they must take this course because it includes elements of project management and process, as well as just software engineering techniques. So it's considered a very important part of the program. The elective topics include the ones that I've listed here. Recently, we've added, in the last 6 years, we've added robotics. And we also have a specialist in human-computer interfaces who focuses on tablet-based type of computation that uses sort of sketched, inferring knowledge from sketches that can be turned into objects. So essentially, for example, sketching a circuit diagram and having that become objects that could become part of a digital simulation would be the kind of thing that they do. It's a very interesting AI type of application. In 1997, we were the first undergraduate college to win the ACM International Programming Competition. And I believe that year actually was a year that Microsoft sponsored the competition. I believe it might have been the last year that they did so. And since that time, there was only one other North American team that won the competition, and that was University of Waterloo 2 years later. So it's become a very rigorous competition to win, and the original field starts with 1,000 colleges approximately competing, and then they're narrowed down by local competitions until you get to about 50 teams that compete in the finals. The finals entail a 5-hour competition in which 8 problems are being solved, or being attempted by the teams, and they're penalized for false solutions that are submitted. They don't get to see the answers. They just get to submit the problems to the judge. So we're very proud of the fact that we did win that. Another first place in the area of robotics, we were the only team to complete the scavenger hunt competition that was in the 20th AAAI conference on robotics. And we actually did it with a robot that was put together with parts that total less than $600. So these are the team members that won that competition. We also do very well each year in the so-called mathematical modeling competition. This is more oriented toward mathematics majors, although some computer scientists do participate. And each year we do tend to have a very high rank in that competition. This year we shared the top honors with Rensselaer Polytechnic Institute. In the Putnam exam, which is mathematics competition we were discussing earlier, we're coming in in the top 10 places, mostly in the last few years. And this is out of a competition of about 500 schools in the area of mathematics. So it is, again, a very prestigious level of placement. We also have one of the highest participation rates in the nation in this competition. And this past year, we had an undergraduate woman who was this runner-up, which is basically the second place in the CRA, Computing Research Association, undergraduate award. There's one award given to a woman and one award given to a man, and then there's a runner-up in each of those categories. She happens also to have been one of the members of the robotics team you might recognize. So we're quite proud of her. These are our faculty. As I mentioned, we have 9 faculty, and all faculty at Harvey Mudd have a PhD. There's the schools they're from and the areas in which they specialize. And we also have recently a new president, Maria Clave, who is nominally a computer scientist and mathematician, and her husband, Nicholas Pippinger, has joined the math faculty at Harvey Mudd. And we also have at Pomona College, which is one of our affiliates, Kim Bruce and several other computer scientists. So total, we're talking about maybe 15 faculty members in computer science at large in the Claremont colleges.
You're probably aware that Maria has been very involved with us, and she was active in our faculty summit, interviewed Bill Gates on stage at our faculty summit.
I wasn't aware of that part.
Active in the selection of our new faculty fellows. He sat on our external panel for selecting our Microsoft Research and faculty fellows. So,
Okay.
Congratulations. We really love Maria. She's great.
Okay.
I think you've been an excellent person there.
Yes, we agree. Thank you. So getting on to the clinic projects that we've been doing, these are the projects that we did last year with 7 different companies. Aerospace Corporation, we did a project in doing a grid-based parallel implementation of biometric surveillance using neural networks to do face recognition. The team did not develop the face recognition component. They simply integrated parallel copies of this component to produce a grid-based version of the recognition system. Arriva T&D is a company actually in this area, and they do power grid management, and we were working with them to explore the idea of using video game-based technology to provide a new kind of interface to power grid management. With Boeing Company, we did a parallel simulation of the GPS ground system for the future GPS. So this is another networked application. Fair Isaac Corporation is what they do is they do things like your credit scoring. They assess risk for things like credit card risk or mortgage application risk using the neural network type of technology or support vector machines, that sort of thing. And we worked on a product to visualize business rules, one of the facets of their business. With LaserFiche, this is a company that specializes in managing documents based on images of the documents, some of which are captured just using the handheld digital camera, for example. And so the project last year happened to be a document filing application, but now we're actually working on the actual image processing itself. And NC4 is a company in Santa Monica that is interested in providing information about disasters. So if you have a company and you want to know what's going on around the company that might have some effect on the company's operation, like some kind of an incursion or something like that, they would provide up-to-date information based on a combination of web feeds, police broadcasts, and so forth. And with Sandia, we worked on the implementation of a object-based file system simulator for their large supercomputer called ASCII Red, or its successor, which hasn't been released yet. And this current year, almost all the projects, almost all the clients that we had from the previous year actually returned, with the exception we picked up one new client, which was Los Alamos National Laboratory, and there we're doing a kind kind of a animation graphics for a museum to demonstrate some of their accelerator technology in the museum in Los Alamos. So it is common for us to have repeat clients, but maybe not as many as would be indicated in this current year. Over all the years that we've done Computer Science Clinic, these are the sponsors that we have had to date, including 3 projects with Microsoft, although none very recently. So we're hoping to change that. In our development, the students are relatively amphibious as far as what languages they can work in, so they're very quick study. We have some of them in the room here. I'm sure that you know that they are. And we also are willing to work with lots of different platforms, hardware and software bases as well. So that aspect is not really an impediment to the type of project that we're able to do. We, as I mentioned, all students have some experience with project management from the software development course, and we use requirement solicitation, things like use cases. Students develop work breakdown structures, PERT charts. They use UML, design patterns. All of the kind of contemporary technological ideas can be used and are used in clinic projects. So to give you an idea of how the timeline works, things begin like now, for example, January. Throughout the spring, we are prospecting for projects for the coming academic year, which will begin in September. And then over the summer, we try to firm those up with a definitive statement of what the project is, although there still may be some loose ends that have to be tied down once the students begin working on the project. The students start on the project at the beginning of September. We have an orientation day where all the liaisons from all the companies come to campus, meet with the clinic directors and with the faculty supervisors and with their teams. And at that point, the project is formally launched. The team does its own structuring of its members. It has a project manager, which is a student in addition to the faculty supervisor. We produce a statement of work at the end of the first month that tries to nail down as specifically as possible what things we're going to be delivering at the end of the year. And then throughout the fall semester, we have design reviews. We have a first review, which is the students' understanding of what is the project really about, and they explain that to all their peers in the department. Then that's followed by a second presentation, which gives their progress report on the particular project they're doing. Yes.
How many students are in one team?
There are 4 typically, although sometimes 3, sometimes 5, but almost always 4. And then at the mid-year we have a break. At that time we deliver a mid-year report, which is a report on progress and also a plan for the next semester, which is what's going to happen, how it's going to be executed. The work continues in the spring semester, and we have additional presentations on progress at that point. And then in May, we have the final report, which is detailing all the work that has been done, and also final presentation on campus and, if desired, at the sponsor site as well. So,
So what kind of computing facilities do you have at the site?
Computing facilities?
Yeah.
Mostly relatively current PCs and laptops, but mostly PCs. If you want the specific brands, the generic thing we would purchase would be a Dell probably, and we have a lot of those. But we can also tailor things to this project's needs. If they want something more specific or more power, something like that, we can do those kinds of things.
From the sponsor's fund.
Yes, and the fund for the project is $43,000. It's a fixed cost per project, and unless it's really unusual amount of equipment needed, we would take it out of that.
So the
Yes.
ongoing, day-to-day supervision of this is done by the team and the professor.
That's
not
correct.
us. So
And
you're acting more like a vendor hired by the sponsor to deliver something.
well, okay, so let me add a little bit to that. There is a liaison. And the liaison normally would make a weekly conference call with the team if not an occasional face-to-face visit, at least once per week a call would be expected. So it's not quite the same as just throwing it over the transom and waiting for the results to come back. And the Liaison also can function as a source of domain expertise for things that are specific to the company that wouldn't be not be common knowledge. So that's another purpose of having the Liaison.
But the sponsor provides the money and then also the problem.
Yes.
Something
And the Liaison, yes.
Okay.
Yes.
How much experience do the students have with group work before they get to this course?
Uh-huh.
And how successful are they at actually completing their projects? Like, do any of the groups self-destruct along the way?
Well, it's a requirement for graduation, so if they the group almost never self-destructs. Maybe one or two individuals might, but that's fairly rare. If somebody just decides to drop out, it can happen, but it's a very small percentage. In terms of the success rate, I would rank it probably 80 to 90% success rate of the projects. And I'll show you in a moment some of the instruments that we use to evaluate that ratio, so you can get a better idea of what we look at. And your other question was about team background.
Team background.
Yeah.
How often they work together? For the teams
So-
that also work on the groups together at the clinic, have they worked together before?
And they have worked in a group, but not necessarily the same group as in the clinic project. So in the software development class, for example, they will have done between 2 and 3 team projects, and usually it will be with the same team throughout the semester. So that's a one-semester class. It's not uncommon to have teams of a smaller size in other courses. For example, we do some pair programming in our program development class, which is a predecessor to the software development class. So there's pair programming there, and even in the introductory classes we may do some pair programming there. So generally teamwork and presentations are very common at courses at Harvey Mudd. A lot of the courses do require projects as part of the term requirement.
One thing we might add is that we don't have the results from last year, but 2 years ago in the 2004-2005, we had 13 patent disclosures filed out of 35 projects. So.
But that's mostly engineering department. We should, in fairness, say that there aren't that many software patents that are coming out, although we have had at least one, I think.
Well, you might distinguish the role of the faculty versus a typical project where you have a principal investigator led by a faculty team where clinic is significantly different.
Yeah, the faculty is there for not to dictate or to manage, but to rather suggest and steer. So it's kind of like more behind the scenes, you might say, although the faculty does play a second role, especially in computer science projects, of being an idea generator. So in that sense, the faculty member is a part of the team that can contribute to the ideas for solving the problem. It's not like it's all in the students' hands and we expect them to come up with everything.
So when students have some questions, do they mostly go to the faculty or do they mostly go to the industrial liaison?
It varies. It varies. It depends a lot on the project and how busy the liaison is, but both are used.
Somehow they too have to get together often in order to understand the problem.
Yes. The team has to meet more than once a week, obviously. They're putting in about 10 hours per week as a team.
How often does the industrial liaison have to go there to visit?
It varies depending on the geography. Sometimes it's once every 2 weeks, and sometimes it's once a month. Sometimes it's once a semester. So it'll vary quite widely.
But they do have about a 1 hour status update weekly, usually a teleconference.
Yeah.
So this counts as a class for the students?
Mhm.
So it's 1 minute they're taking
It's a required class.
They're taking the regular course load.
Yeah, they're taking other courses, that's right.
Because most of the faculty have industry experience.
About half, I would say. Yeah.
How do the students organize themselves? Are they all developers, or is there one person who's a manager and one tester?
I would say everybody, to some extent, does some development, although the project manager, there's a designated project manager, and that person does a little bit less development and a little bit more coordination and management. It's also possible for our team to elect a technical lead, in addition to the project manager, and that's up to the team to decide whether they want to do that or not. Also, I should mention that the project managers are appointed by the faculty. We do ask the students if they want to be it or not, but it's really up to the faculty to decide based on they generally have a good idea of who would make a good manager and will tend to make choices in that direction. So at the end of the project, we not only deliver the final report, we also deliver a CD-ROM that has essentially all the work of the project, the final report, any PowerPoint presentations, any software. If there's a source, usually we're using some kind of a source management tool, that would all be on the CD-ROM. Any other data, and also make a presentation at your site. We also do everything possible to keep data confidential where it's relevant to do that, and even taking steps so far as to put disk drives into safes and things like that, although I prefer not to have to do that, but in some cases sponsors are very sensitive, especially if it's an aerospace company. They tend to be very particular about the way their data is handled.
All the students sign a non-disclosure agreement.
Usually, if it's required. I mean, we don't offer it, but if the company wants to have a non-disclosure, we certainly can honor that. So just to give an overview again of the stakeholders, the team is really doing most of the work. The advisor is providing some additional guidance and insight and expertise that the team typically will not have. The liaison is there to provide domain-specific knowledge and also requirements. The sponsor, of which the liaison is a part, will be providing funding and the need to have the problem solved. The clinic director, that's me, I provide oversight and management over the whole process. And we have one further layer which has not been mentioned yet, and that is the clinic advisory committee, which meets about 3 times a year. And they provide assessment of the overall program and also critique. They actually, when they meet, if there are talks being given on the campus, they will critique the talks in the presence of the students and give an idea, give them feedback. Yes?
You mentioned before that a lot of your students go on to advanced degrees.
Yes.
But it would seem with this program that there would be a high gravity of these students going to work for the sponsors for whom they did the programs.
Yeah.
Can you just explain that balance a little bit?
Well, so the figure I quoted was Harvey Mudd as a whole, and I'd say computer science, actually, the ratio is probably a little less than that because you can actually get a very good job without having an advanced degree. So the ratio is probably closer to 30% in computer science. Some people do immediately go to work, and some people go to grad school, and then later may come back and work for the sponsor. So it's variable. Excuse me.
How frequent is it the case that the sponsor will hire the people who are on these teams?
I would say probably about 25% of the time. So maybe one out of 4 students on a team might be hired by the sponsor. And sometimes sponsors will cross over and hire people off of other teams that they like what they're doing. Excuse me. These are some of the members of our current advisory committee. Excuse me, I'm just getting over something. I've listed the ones that are kind of closer to computer science, but the actual committee is about twice the size. The committee is empowered by the trustees of the college, so it does have quite a bit of clout. And this is our recent example of our recent liaison survey. So the liaisons of the projects, so you see the columns correspond to projects, the rows correspond to questions that are asked of the liaisons, and you can get some idea of what we're interested in. How did the team meet its goals? How well did it manage? How creative was it? How well did it communicate with the liaison? How effectively were its presentations? And did it actually develop something that's worthwhile? And there's additional set of questions that I haven't listed here that have to do with more of the internal management of the program itself. So this actually is a pretty good set of scores. I won't say it's the all-time high, but it's not the all-time low either. But usually we're above 4 out of 5 average for most of the projects. I can't take too much credit for this because this particular year was a year I was on leave, which was last year. So my stand-in certainly did an excellent job, or his team certainly did. Let's put it that way. Here's just a couple of clips out of unsolicited reports from clients, just to give you an idea of the degree to which they're satisfied with the results. This was the Applied Biosystems project, and that the students developed a new version of software for a PCR machine, which is a thing that does assessment of DNA, basically. And another project from a couple years back, in this project, which was to use to develop a simulator for asynchronous logic of a particular flavor, the team actually developed its own VHDL compiler to boot because they weren't happy with any one of the available VHDL compilers. So it's kind of a bonus as a result of the project. And so before I get into the specifics of the project, I show you some slides of specifics, just to say that we are interested in addressing your requirements. The requirements can be both technical, performance-oriented, and ergonomic types of requirements. And the range of projects can go from anywhere from current practice to something of advanced research that might not be in a product immediately, but some idea you just want to test out. So here are a few examples. What I'm doing here is I'm using a poster which the teams produce in addition to all the other things they do. They have a summary poster that is available on Projects Day, and you can walk around and discuss with the teams their projects. This is the poster for the Fair Isaac Corporation project that was visualization of business rules. There the idea is you have a tremendous number of rules, and you do things like clustering of the rules together so that you can visualize the overall thrust of the set of rules without having to see all the detail exposed at once. In NC4, this is the company that does the disaster communication management. The team produced a system a web-based system to assist their human monitors to monitor situations, and used a fair amount of text classification type of technology, which seems a very popular topic among projects that we've been doing. In Sandia, the object-based file system I mentioned before, it's a simulator. Actually, this is going on for a second year now, and this is to the level where we're actually simulating very fine-grained behavior of disk systems to get performance statistics from those systems to determine what the impact of the specific disk will be on the overall file system performance. LaserFiche, the company in Long Beach that does processing of image documents, we're working on how to de-warp and make other kinds of transformations on images so that the text in the image can be recognized. So we're not actually doing the optical character recognition of the text itself, but we're pre-processing the images to enable the optical character recognition to be done. And this actually is being a second phase of this project is going right now. So the kinds of things that we're interested in doing is take a digital camera, hold it at some arbitrary angle, and take a picture of it, and then have it understand the text that's in that picture. This was a real-time project for a company that does insulin monitoring in diabetics. And in this project, I think the students did about 30,000 lines of Java code using Eclipse, and everything was unit tested. It was demonstrated on Projects Day. It actually worked as a product, and this will be the basis for future lines of these kinds of monitors by the company. And Cryptek is a company that makes standalone units that do encryption of data on a network. So here we're trying to do kind of a stress testing of these nodes that the company manufactures, which they had not been able to do. And we use software simulation to build a model for testing a network of these encryption nodes. With Northrop Grumman, an aerospace company close to campus, we developed a system for detecting anomalies in health and safety data that are being sent by satellites. These would use techniques such as adaptive signal processing and other kinds of techniques that would allow the system to inform the user of a suspected anomaly, and then the user could confirm or deny that it really is an anomaly, and the system would learn that to either report this kind of thing in the future or to ignore it, depending on what the response from the user would be. This would take the place of users poring over large numbers of spreadsheets to try to determine whether something is anomalous in the data that are coming from the satellite. And with Qualcomm, a division called Snaptrack, we developed some mobile phone applications. Another type of mobile application, I don't really have a slide of it, but with Microsoft we developed the first handheld browser for Sidewalk, which was an early version of Cityscape. So that was a project that was done a few years ago. And we also did a position-independent compiler for the cell phone compiler that is used by Qualcomm, based on GCC. With Aerospace, we've developed a number of projects involving security protocols and intrusion detection. And we also developed a real-time launch range timing system. This is a distributed network of timers that are for use in the Vandenberg missile range. This has not been deployed yet, but it is being proposed as a model to which they can upgrade their current system, which is fairly archaic. And we've also done, in the kind of intrusion detection area, work with Raytheon on using the human immune system as a model for intrusion detection and prevention. So I could continue this for a long time. Should I say something about the non-clinic research, or should we take questions now, or what would be a good? Yes. Go ahead.
You said Microsoft sponsored 3 projects. Since we're not in Southern California, how would that work with the Liaison?
As I mentioned, we do the telecon, and so I think my memory is not totally good on those, but I think 2 or 3 visits were made to campus by the Liaison.
Microsoft in Redmond,
Yes, it was in Redmond. Yes, that's correct.
So is the product group or research that funded that project?
I think in the one case it was the Excel product group, and in another case it was a .NET based product, and it was when .NET was really new. So I think it was product group in that case, and for the Sidewalk, probably product.
So actually, I myself was actually industrial liaison at the UCLA.
Oh.
It's called Applied Mathematics
PAM.
summer project.
PAM.
With PAM.
IPAM.
With one of your professors as a director.
Mike Rao.
Mike Rao. Yeah,
Yes.
exactly.
Yes.
So it's very, very useful for us. Actually, I just wonder in terms of the organization at your school versus at UCLA.
Yes. Well,
is that similar in terms of organization?
Similar. Now, the difference is that IPAM is done in the summer, and so it's condensed in a time frame. And I think the teams are different size. I'm not sure about that, but there is a similarity. I believe the idea actually came from Harvey Mudd and was picked up by IBM.
So that's how I get the name.
Yes. Very much.
When you said there were 2 visits to campus, you meant Harvey Mudd campus, right?
Yes. I'm sorry. Yes, to our campus. Yes, sir.
They have popularity problems. Everybody wants to go on to the same project.
That does tend to be an issue, yes, but we somehow resolve it. We ask the students to rank their preferences, and we usually end up giving people not worse than their second choice, but it is a load balancing act to get that.
So my experience with IPAM project at UCLA last year was that it's quite critical to have a faculty at the school. At that time, just UCLA has a professor who worked in exactly the same area as our group is working on.
Yes.
So we know each other background quite well. So the students, can actually get really good advice directly from the faculty there.
Yeah, we can't necessarily offer that because we.
University bigger, that's more.
Yeah, I mean, we have to be more adaptive, and but I think the faculty are quite open to learning background material that is needed to help the students.
So what kind of commitment do they make in terms of their time?
The faculty,
Yeah.
they would be spending probably half day a week on the average, something like that. It'll vary a lot depending on the project, but we like to have the students take the main ownership of it and have the faculty be more advisory, especially in the early stages where a lot of brainstorming goes on. The faculty members are there as of a team member, actually.
So in addition to IPAM at UCLA, does your school provide similar kind of directorship for other universities for similar kind of projects?
I think that connection was, we weren't providing it as Harvey Mudd, it was just a faculty member who had a second appointment. So we weren't subcontracting to UCLA.
Okay.
But actually the previous director also was from Harvey Mudd. That started, I think he was actually one of the starters of IPM, in fact.
That's a really good.
Yeah, it's a nice
Certainly
model.
of equal importance, though, is the liaison. If you have a highly motivated liaison that really takes ownership of the project, you're going to end up with a great result.
Yeah, it's if the liaison loses interest or gets transferred or something like that, it's not a good sign.
One advantage with your school rather than UCLA was that IP issue. We actually got our lawyer involved for 2 weeks.
Yes.
Just to negotiate with UCLA lawyers.
You probably spent more than the cost of the project.
This is something I feel totally wasted of time.
Yeah,
Our program couldn't work that way.
No.
It literally would fail because come September the 11th or so, we have to have 35 projects ready to go. And
although it's
a big selling point is the IP issue, and it eliminates a lot of cost and complication and get the projects going.
Yes.
The process you outlined, you said you do use cases, you do requirements, use cases, work breakdown, Gantt charts. That comes from Harvey Mudd, right? That's your.
Yeah, I mean, if the
sponsor
sponsor wants us to use a different model or a specific model or to use certain coding standards, as long as they're willing to share with us what those things are, we certainly can comply with a different kind of model.
The real question is, do you ever find that after the students do, or my question generally with this, any kind of internship co-op, is do the students bring something back from the industry and say, we didn't know this, you need to teach us, test-driven development or something, because it's out there, we're not learning it. And I was wondering if that happened with this program, but it sounds like maybe with you guys defining the process, that wouldn't happen. Would it ever happen with the curriculum?
Well, part of the problem is that they're doing it in their senior year, so it's maybe too late to actually come back and say, but we do have people after graduation tell us we should have learned more about that topic, and we try to do what we can. We're limited by the number of courses that we can require in our major. The college says put a ceiling on things. So, test-driven design is certainly a topic that we do talk about, and it would be nice to even have that as a course.
Right, I was thinking maybe that software development class.
Yeah, definitely.
Another aspect of what you're talking about could be the feedback we get through our corporate advisory committee and the clinic advisory committee, which might result in the fact that Harvey Mudd doesn't have the most up-to-date equipment to do this certain type of clinic. And then we definitely will take action to try to improve in that area and get updated.
But that doesn't happen much in computer science. Maybe
because the question Microsoft gets asked by universities sometimes is what should we be teaching people if we're not? And so I was wondering if
I was mentioning that discussing with Jared earlier. That's one of the things that we could conceivably gain out of a relationship would be, if you could tell us what you would like to see in the students coming out of Harvey Mudd or even in the projects, we can try to bring that down into the curriculum and sort of beat the game in a way.
So your students must also take summer jobs.
Yeah, it's very common.
How do they compare that experience versus the clinic?
The clinic, well, I think the clinic is much is more demanding in terms of their intellect than a typical summer job would be. So often they're slinging code. Sometimes they really do in product development, but I think the clinic generally is more challenging.
So they give it's more challenging, more responsibility.
Yeah, and we actually seek out problems that you don't know the solution to. I mean, we don't want something that it's just a routine thing. We know you can do it, just go do it. It's not that kind of thing. The things that really engage them more are the ones that are open-ended and they don't know exactly what the solution is going to look like. Yeah.
How often are the projects that are proposed by the companies, how often are those kind of like too advanced for the students to be able to do?
Very rarely. We
What
use
kind of negotiation process is it?
So that is in that first month when we end up with a statement of work. We start with a description which may be 1 to 3 pages typically, and then you can ask for the moon in that statement. Of course, if it's too far out, I won't accept it as a project, but that rarely ever happens. But there's some negotiation that goes on, but the liaison has to be reasonable and understand these are students. There's a limit to what they're going to be able to deliver, but still at the same time we want it to make it challenging. So that first month kind of ending up in the statement of work is where most of that takes place. I won't say that there haven't been projects that fell short of their original goals, because sometimes it's a so-called what's the term, wicked problem that you don't really know how bad it is until you try to solve it a couple rounds.
So do students get paid out of the
No,
sponsors
they don't
fund?
get paid. So it's we have a rule that they can't get paid for course credit. So the money goes to essentially support the college infrastructure for the program.
Pays for the travel, if the team comes up here twice during the year, there's an expense there. Maybe computer science aren't as expensive in terms of engineering has a bigger budget because they're usually coming up with a prototype and there's equipment to be purchased and so forth. And then there is an overhead component to support the school too.
But we've heard a lot of comments that say it's a pretty good value for $43,000. So yes.
One of the areas that we're interested in is attracting more women into the computing and computing-related fields. And this is actually something I know that's near and dear to Maria's heart.
Yes.
Spoken to her at length about it. Do you see any trends in involving women in computing in your clinic program? Or is it easier to perhaps attract women into projects because it has a tangible outcome?
I don't know if the latter is true. We did have a very good trend going with women before the bubble broke, and then something it sort of it seemed like it was disproportionate, the number of women dropping out of what would have been a computer science. But we do have a third of our faculty are women, so we think that particular impediment is absent. And I think there is somewhat of a trend, especially this year when we sponsored a number of students to go to the Grace Hopper conference. We actually got quite a few women signing up as computer science majors. So that may be one of the kind of key things that we can do to increase the ratio. I don't think it's a
for the 3 days, I think, too.
Yeah, she was there, and I don't think it's a permanent problem. I think we can work that problem, but I'm not sure how much clinic really, one way or the other, helps it.
Well, there are some other programs that we know of out there that are based around field experience, but particularly from a socially relevant point of view. So the notion is that you go out into the field and you work on computing problems, but the tangible outcome is some sort of societal benefit in education, in healthcare, in what have you. And that seems to also be attracting women in computing more frequently.
Well, then if that were true, then I think that the clinic actually might help in that regard. Another aspect is we do have a professor who's interested in the issue of gender in video games, and as we know, traditionally girls have kind of been excluded, and she's trying to examine that issue and do what she can to suggest some ways that it might be changed. So we do have a very active program in that kind of area, and it's actually tied in with the software development because she teaches that class as well. So we're trying to do something.
Right. Well, I think we're pretty much running out
All
of
right.
time here. I just add one note. I brought Bob in as a supporter of this program because I've actually been through it myself, and I know some of these questions arise that in my particular clinic program, which was in the year 2000, a patent did generate out of that particular one. We went to a presentation at a conference over what we came up to, actually a conference in Paris. I ended up with a job in research at IBM at the time, and I put that job booking through college, and eventually led to me coming here and working in research as well. I mean, there's just this particular program was great for me for my career in the future, and it's also pretty good for every student and the participants, the corporations that are involved. Part of this was just to give an explanation of what the clinic program was. Part of it was also to see if there's some interest here at Microsoft. We can talk to both Bob and Barry about that kind of thing, but just because I'm in the group, the Extended Research and Programs group, I'd like to hear about anybody who might be interested in doing that kind of work, and at least to have some sort of coordination for efforts here at Microsoft. And my name is Jared Jackson. Jared J is my name is here. I also sent out. I was the host on this particular. So you find me that way. All right. Thank you.
Thank you for having me.